Howdy, hi, this is George with Home Brewing Company here in sunny San Diego. It's winter time, so that means it's about 81 degrees Fahrenheit and very, very dry. So, all right, today we are here to talk about refractometers and hydrometers. What's the difference between those things? We do already have a pretty short video talking about hydrometers and how to read those, but we get a lot of questions about what's the difference between a hydrometer and a refractometer, when is one better over the other, etc. And we also get questions just about like what's the difference between Play-Doh and bricks and starting gravity and final gravity and specific gravity, all that stuff. So today we're just going to go over that. Hopefully this takes, anywhere from 5 to 500 minutes. Cheers. Grab some beer. So, the goal of a hydrometer and a refractometer is pretty much the same thing. We are trying to measure the density of a liquid. In this case, we're trying to measure the density of our worts, which is unfermented beer, or our must, which is unfermented cider or mead or wine. And the reason we're trying to measure the density is that the density is going to tell us basically how much sugar is in that liquid. I'm going to wait for this fire truck to go by. Woo! As I was saying, the purpose of measuring the density of a fermenting beverage is to try to basically figure out how much sugar is there, and we can use that to also figure out how much alcohol is there. It's also a great diagnostic tool for just trying to understand whether or not we have a stuck fermentation or if fermentation is about to end, those sort of things. So we use them frequently throughout the entire process to gauge exactly where we are and to just look for consistency. So if something's a little off kilter with the fermentation, the hydrometer is usually one of the best tools for figuring that out. What is a hydrometer? Well, a hydrometer is an apparatus made of glass that has a little weight buoy on the bottom. And this weight buoy is designed to make the hydrometer float at a very specific place if it's just sitting in, say, very pure water. Then on the stem of the hydrometer, there are some markings or calibrations that will tell us how dense the liquid is based on, in our case, how much extract or sugar there is in that solution. Why do we want that? Well, at the beginning of fermentation for a beer, we typically start our gravity at 1.04 through 1.07. That's going to cover most of your like 4 to 8 to 10-ish% beers. I said 8 to 10-ish because, well, it also depends on your final gravity. So we actually need our original gravity, so before fermentation, and our final gravity, so after fermentation. We take those two numbers, plug that into a really simple formula, and that tells us the alcohol by volume. It's the best tool for figuring that out, but it's also, like I said, a good diagnostic tool. When people call into the shop or they come in and they ask, hey, I've got this fermentation that I started 2 days ago or a week ago or I don't know, and it seems to be stuck. I don't know if anything's happened. Well, we have visual cues, right? We can look for foaming or the croissant on the top. We can look through CO2 bubbling through the airlock, but those are just kind of visual clues. And they're not really the cause of fermentation, right? Like the best way to tell if fermentation is actually happening and going well is to see how much sugar is being consumed by the yeast, right? So are the yeast actually eating? Well, if they are, then don't worry about it. It's probably good. If they're not eating at all, and we have proof of that because we know where it started, and hey, 2 or 3 days later, it's still at that number, okay, that tells us something's up, and we need to do something in order to encourage this yeast to get to action, get to work. I have a few hydrometers here. This is kind of your standard homebrew scale hydrometer. And then each of these hydrometers are what we call precision hydrometers. If we look at the standard homebrew scale on the specific gravity there, it's a pretty wide number. So each of these little hash marks equals 2 whole points, and they're really close to each other. So it's kind of hard to get a really accurate reading. With precision hydrometers, they shorten the scale a little bit, so that's in, let's look at this one. In this case, we're starting at right up below like 1.01, or 1.00, sorry, like right there. And we're only going up to 1.02. So each of these hash marks is a little further apart, and it goes from like 10 to 11 to 12. So it's really easy for me to see where my, in this case, final gravity or finishing gravity is. Okay, so what's the difference between a hydrometer and a refractometer. So this is a refractometer. Both of these devices, hydrometer, refractometer, measure the density of a liquid. The way a hydrometer does it is by actually floating in the liquid. So that requires a good amount of liquid so that it can actually float. That might be a bummer if you're doing a 5-gallon batch and if you're trying to take a good amount of readings, you're kind of losing volume at each point. Also, if you're a winemaker, let's say you wanted to go see like how are the grapes doing. We're getting close to harvest. I'd like to know, should I start harvesting those grapes, or should I wait and let more sugar develop in the grapes? Now, if I had to go around with a hydrometer and take a bunch of grapes and squeeze them and fill this up, it takes a lot of time and I'm going through quite a bit of grapes. But if I'm either in the brewery and I just want to take a small sample, or I'm in the wine vineyard and I want to take a small sample, all I need is one tiny drop of liquid here. I close this up, and if this was just water in this sample, the light would refract through that water at a pretty known level, and when we look through the refractometer, we can see a blue line typically match up to a little scale that's on the inside here. So I can say, oh, if it's water, it should be reading at 0. Just like a hydrometer, when it floats, if it's just water, it should be reading at 1.000. But now if there's more density in this liquid, whether it's here or in the hydrometer is going to float a little higher because of that density. The refractometer, the light will refract or kind of bend off of that liquid in a different way. And basically a bunch of cool, nerdy scientists, thank you very much, went through and they started adding known amounts or known weights of sugar to samples, and then creating these little tables and taking these samples that said, okay, when I added 1 gram of sugar, the light refracted this way, or the density in the hydrometer went up to this amount. And when I added 10 grams of sugar, it went to this amount, on and on and on. So we have these different scales that basically tell us just how much sugar is in our sample. That's really nifty for finding out how much potential alcohol we have and how much fermentation has progressed. Even though it's really, really nifty for taking really like good on-the-fly readings, say in the vineyard, or during brew day, like taking a sample of some hot wort, cooling it to room temperature. I only need a little bit, so it's pretty quick to cool down. I can take a sample, cool it off real quick, put 1 drop there, get a reading. That's awesome. The bummer with refractometers is, as this ferments, the yeast are consuming the sugar, so that's good, but they're also creating some alcohol, and alcohol refracts differently. So that is going to change the actual reading. It's going to skew it. Bummer, right? But there are some calculators you can find on your favorite Ask Jeeves or web crawler search engines. Some brewers only use the refractometer on brew day because it's really nice to be able to just take a small sample, get a reading really quick, instead of waiting to cool down a larger sample of like 20 to 30 milliliters in order to just get a reading of like what is our pre-boil gravity, what's our final gravity, that sort of stuff. We tend to just use the hydrometer for all of our readings. From time to time, we'll pull out the refractometer just to kind of compare, but we tend to rely on the hydrometer a little bit more. That's up to everybody to kind of figure out on their own and see what works for them. The other thing you need to note with a refractometer is that you should calibrate it, I would say, every brew day. The way you calibrate is you get some pure water, distilled or reverse osmosis is best. You could use tap water, but the density of that tap water might be a little off. And you put 1 drop of distilled or reverse osmosis water right there, look through, and there's a little tiny screw that you can adjust where that blue line matches up. Really easy to do, but something you should note if you own a refractometer or you're thinking of buying one. You should just get used to the word calibrating it from time to time. It's really easy. So let's talk really quickly about the different scales. One of the first of those scales was by this dude named Carl Balling. Balling scale is pretty accurate for measuring sucrose in a solution. Later on, the Brix and Plato scales came along to sort of refine those, kind of update those tables, looking at different parameters, maybe different temperature calibrations. That means that when it comes to Brix and Balling and Plato scales, they're pretty interchangeable. Of course, they do change a little bit. For all intents and purposes, if you're just trying to get a kind of a good gauge on where you're at, they're pretty interchangeable. Or if you're having a conversation with someone and they're talking in Play-Doh, but you're used to bricks or vice versa, you can pretty much say that 4 Play-Doh pretty much equals 4 bricks. There are, of course, tons of charts that you can find, or little calculators to help you figure that out. It does get a little less accurate the more sugar you have in there. That's fine. It still kind of holds true pretty well. In addition to bricks, Play-Doh, and balling, most home brewers in the United States, and a lot of pro brewers because of that, especially brewers in the UK, do also talk in specific gravity. That basically is the same thing as talking about the density from Play-Doh or bricks or balling, but the scale is a little bit different. The scale is actually pretty easy to convert. So if I'm talking 40 gravity units, I divide that by 4, and that means I have about 10 bricks or Play-Doh or balling. If you take your Play-Doh or your bricks or your balling, multiply by 4, you're going to get essentially a pretty accurate translation of the gravity units. Let's take a quick little sample here. Here we have a red ale that we are playing around with in the back, a little 5-gallon batch. And I'm going to take a gravity reading with it. But since this is fermenting, that means there's going to be some CO2 in there. And the CO2 can actually make our hydrometer float a little bit more, gives it a little more buoyancy. So it can throw off our density. So I'm going to shake it for a minute. So this is our little method. We also like to use this little egg beater whisper thingy, and we just go like that until we knock it out. So we'll do that a few times until we feel like there's less foam. Then we fill our tube. There's going to be some foam on the top, right? Because I just whipped this guy around, right? Put that in there, drop my hydrometer, give it a little spin. I'm gonna blow off some of this extra little foam. There we go, big messes. And you're gonna read at the bottom of the meniscus. You actually wanna read at like the main level of where the liquid is. And in this case, I'm floating at 1.01, next hash mark down, 12, and right around there. So I could say this is at 1.012 or 1.013, right around there. The next thing I need to do is take a thermometer reading of this and get the temperature, because this hydrometer in particular is calibrated to 60 degrees Fahrenheit. So I'm going to get my nifty-difty either Beersmith or whatever. You can find like free brewing tools and calculators and apps either for your phone or just, search it. I'll plug that in. I'll say my gravity reading was this, my temperature is this, and my hydrometer is calibrated to 60 in my case, and that'll give me a little adjustment. One thing that we notice brewers get really confused when they look at a hydrometer is that when we look at this, we're going to see 1.050, right? So that's 50 gravity units. That's the density of this liquid. Now, if I go over just 1, I see this percent ABV. So I go, oh, cool, 7. So they think, oh, cool, I have 7% ABV. No, you actually have the potential for 7% ABV. Now there's 2 points to this, right? The first point is you can't skip taking your gravity reading on brew day and getting your original gravity, and then just take your final gravity and say, oh, this is how much alcohol I have. Because in this case, when we take this gravity reading, we finish at 1.012. So if I go from there, I go, oh, I only have like 1% alcohol. Bummer. That's not actually the way this works. We need to take the original gravity and the final gravity, plug those two numbers, and that's going to tell us the alcohol. Now the reason, again, if I look at 1.050 and I go over and it says, oh, I'm going to get like 6 to 7% alcohol, cool. That's only if all of that density is made up by 100% fermentable sugars. In other words, that means that our final gravity is going to be 1.000. The truth is that when we measure density, yeah, we're measuring a lot of what the sugar content is in there, but we're also measuring non-fermentable components that we might pull from especially in beer, from the grains. So we do need the original gravity and the final gravity. All right, that's it on our little spiel about refractometers versus hydrometers. If you have any questions, please feel free to type them down below or shoot us an email, brew@homebrewingco, on the Instagrams, homebrewingco, those things. Use your search thingy and find us.